Hello, welcome to Jisun Park Science Lab. Today we will study the temperature scales, which are the conversion from Fahrenheit to Celsius. Here you can see the ice, frozen one. Do you know which temperature makes water into ice? That is 0 degree in Celsius. This is a thermometer that shows both Fahrenheit and Celsius. The left side is for Fahrenheit and the right side is for Celsius. Let's think about the thermometer. How does it work? A thermometer has a glass tube sealed at both ends and is partly filled with a liquid like mercury or alcohol. When this liquid gets hotter, it expands. It increases in size by a certain amount that is directly related to the temperature. The liquid that is contained within the thermometer may be different. Mercury is hazardous, so low hazard biodegradable liquids are used. Here we see the temperature of the ice. It is 0 degree in Celsius or 32 degrees in Fahrenheit. As you see here, we are observing one aspect with two different temperature scale units. They are the same, simply different scale reading. Now let's measure the temperature of boiling water. The water boils at 100 degrees Celsius. The temperature of the boiling water is 100 degrees C in Celsius and 212 degrees in Fahrenheit. So 100 degree Celsius equals 212 degree Fahrenheit. Also, 0 degree Celsius equals 32 degree Fahrenheit. Let's look at the scales. In Celsius, the unit scales are 100 units. The Celsius is an SI International System of Units. We use this temperature unit in science. In Fahrenheit, the interval between the freezing and boiling point is divided into 180 equal parts, while the Celsius has 100 equal parts. 180 versus 100, which could be simplified as 5 versus 9. Here is the conversion formula from Fahrenheit to Celsius. So Celsius equals Fahrenheit minus 32 times 5/9. Because the Fahrenheit degree of the water freezing point starts at 32. So at first you will have to deduct 32 from the Fahrenheit degree. Then match the unit from Fahrenheit to Celsius, which is 9 to 5. It needs to be multiplied by 5 and divided by 9. That is shown as the fraction of 5/9. Let's see the conversion from Celsius to Fahrenheit. Fahrenheit equals Celsius times 9/5 plus 32. From the Celsius degree, we need to change the unit scale to Fahrenheit, multiply by 5 and divide by 5. Multiply by 9 and divide by 5. That is shown as the fraction of 9/5. Then 32 needs to be added. Let's try to conversion here. I would like to convert 50 degrees Fahrenheit into Celsius. So 50 minus 32 first, and then multiply the fraction of 5 over 9. We get the degree 10. 10 degree in Celsius. What about from Celsius to Fahrenheit? 25 degree in Celsius. So 25 times 9 over 5 and add by 32. The Fahrenheit degree is 77. Did you get that? Now let's look at one more temperature scale, Kelvin. K. Here I add Kelvin's water freezing point and boiling point. The boiling point is 373 K and the freezing point is 271 K. The interval between these two is 100, as same as the Celsius. If I explain temperature Kelvin a bit, for every 1 degree C Celsius rise in temperature of a gas, the volume of the gas expands by 1 over 273 of its volume at 0 degrees C, according to the Charles law in chemistry. This means that when a gas at 0 degrees C, which is at 273 Kelvin, decreases into negative 273 degrees C, which is 0 Kelvin, the volume of the gas should become 0. At this time, the temperature at which the volume of the gas completely disappears. That is the temperature at which negative 273 degrees C is set as 0 Kelvin. It is called as absolute temperature. The absolute temperature of 0 K is called absolute zero. At absolute zero, all gas volume of gas becomes 0. Absolute temperature K equals Celsius temperature plus 273. In fact, the volume of a gas becomes 0 cannot be created. This is not happening. This is because most gases already turn into liquids before reaching 0 K. For example, carbon dioxide becomes dry ice, which is a solid at negative 79 degrees C, and oxygen becomes a liquid at negative 183 degrees C, and a solid at negative 218 degrees C. No real gas can be 0 Kelvin. If there is a gas like that with a 0 volume and a 0 Kelvin, we call it ideal gas. Actually, you don't need to know in detail for Kelvin degree this much, but we use this Kelvin temperature for the temperature of the stars. Surface temperature of the stars. Stars are the big fireball. Red star, about 3000 K. Hot. You know the star is big. Here is our sun in the middle. Yellow star, 5800 Kelvin, hotter than red star. Blue star is about 10,000 Kelvin, much hotter, much bigger. Again, temperature scales are Fahrenheit, Celsius, and Kelvin. Have reference points for the boiling and freezing points of the water. Thank you very much.